Hello kids, welcome to Mammoth Online, where all concepts become absolutely simple. In today's topic, we'll talk about very simple scenario of mathematical reasoning. In last video, we talked about how in mathematical reasoning, there are statements, right? And now statements are made up of assertive or declarative sentences. And they have truth values, true or false. Now statements are broken down into simple categories. Now the most fundamental statement we have is called simple statement. Just like how in physics, we have atoms which are indivisible part of matter for the scientists of 18th and 19th century. Similarly, simple statements are statements in maths which cannot be broken down further. So if you remove any part of that simple statement, it will not exist and it will not have any meaning to it. And simple statements are not made up of statements which have their own truth values. Yeah, basically it cannot be further broken down. That is simple statement. And simple statement has its own truth values. A simple statement is generally represented by an alphabet. It could be small letter, capital letter, doesn't matter.
So to summarize, simple statements are basically any statements that cannot be broken down further and its truth value, which is true or false value, does not explicitly depend on any other statements. Now I can give you an example. Let's say cat is a reptile. Now this is an example, but as we know, the statement is actually false. So it doesn't matter. It just needs to have any truth value. Basically it could be false or true. The second example is Africa is a continent, which is actually true. So each simple statements are generally represented by a letter. It can be lowercase or uppercase. For example, the first statement can be represented with a letter P, or you can have a capital P or small q, capital Q, and similarly you can represent with, let's say, A or just B. So these are generally the representation of statements.
Now let's understand negation of a statement. So basically, denial of any statement is called its negation. Now imagine there is a statement like P. So not P statements are negation statements.
So to summarize, negation of a statement is basically denial of a statement. So imagine we had a statement like P, some random statement. Now not P statement will be called its negation. Now in general, in math statements, wherever we have a statement P, not P will have its opposite truth value. So if a statement P has truth value, let's say false, not P will have a truth value of true. And generally negation of any statement, let's say P, is written by this symbol, or sometimes we write like this. All of this are basically representation of negation. The most commonly used is basically this symbol. Now let's see a statement. Now here we have a statement A, which is sky is blue. Okay, let's say this statement is true. The negation of A will be written as, and this statement will be sky is not blue. So this will be the negation. And this statement has truth value of false because sky is blue was true. So this will be false. Let's see one more example. Now we have a statement like P, which is all cats have tails. Negation of P will be not all cats have tails. Now if this statement is true, negation will be false. Now that we understood a general scenario, let's talk about some interesting mathematical examples on this one. Now let's talk about the first example, where we are saying that there is a statement A which is x greater than 5. So negation of A will be simply negation of A is equal to, now the statement is saying x should be greater than 5. So the negation will be x must be less than or equal to as well to 5. Now this will be the negation. Now when we are trying to find the answer, let's say if this is a false statement, and then this statement will be true. Let's see one more example. Now here we have a statement A which is x is an integer. So negation of A will be x is not an integer, or in mathematical notation x does not belong to integers. If this statement was actually, let's say, true, then this statement will be false.
Now there are other statements also. We call it compound statements. Now compound statements are formed using simple statements. The word compound comes from composition. It's basically when we are trying to mix two or more simple statements to form a new statement. that will be the compound statement. So understand, a compound statement can be made from two or more simple statements. And now, two simple statements are connected using something called connectives. So these connectives are also called logical connectives.
So to summarize, compound statements are basically composition of two or more simple statements. So it is called compound statements or proposition. Now let's understand that in much more detail. Now a compound statement is connecting two or more statements. Let's say we have two statements, S1, S2. Now these two should be connected. So the connection between these two statements is called connectives. Now there are different type of connectives. Let's understand each one of them. The first connectives we will talk about is called AND statement. Now in AND statement, two statements are connected by AND, and the symbol for that is this. So the connection between these two statements is basically AND. The second type is called OR. In this, two statements are connected by OR. The symbol for OR is simply upward V. Now there is a third type which is called if then statement, which is something like if S1 then S2, which we have already seen, and the symbol for that is an arrow towards S2. There is a fourth type of connection which is called if only then statement, which is if S1 only then S2, so which is represented double arrow both sides. So all these are called connectives in compound statements.
Now you must be thinking, why do we need connectives, notations and all such things? Because in maths we need all of these things so that we can do arithmetic with them. So just like how we do plus, minus and all those kind of things, we need connectives in mathematical reasoning so that we can do complicated analysis of statements.
So to summarize, all these different expressions which we have used to represent these compound statements or simple statements are called Boolean expressions. So what is this Boolean expression? It's all the representation we have for statements, because this kind of representation help us solve very complicated scenarios regarding statements, and it will be very useful to do arithmetic with statements. So we know that simple statement is represented by a simple letter. Let's say for example here P. A negation statement is simply this kind of symbol. We have AND statement, which is simply a connection between two statements, P and Q. We also have OR statement, which is simply a upward V symbol, PVQ. We have if then statement, which is simply an arrow towards Q, if P then Q. We also have if only then statement, which is arrow on both sides for P and Q. If P only then Q. So kids, these are some different expressions we have to express statements, which will be very useful when we do arithmetic with statements. We will learn a lot more about these in detail in coming classes and how to use them.
So kids, those were some important things regarding mathematical reasoning. I'll see you in the next video.